Thank you, sir.
Okay, good. So I'll start recording it. So just pay attention and just be free in the class. Now let's go. We want to learn the concept of limiting reactants. Observe two reactants A and B going to give us C. This A and B are the reactants, C is the product. Now, before we go into this equation, firstly, look at this conical flask. Let's take, for instance, that we have magnesium carbonate and hydrochloric acid inside this conical flask. When both of them react, you will observe what we call, there's something in chemistry we call effervescence. What do I call it?
Is that when it bubbles? Effervescence.
Yeah, effervescence means evolution of gas. Are we together?
Yeah.
Good. You will observe effervescence of this gas CO2. Now, it will now get to a point whereby you won't observe any effervescence again. That is, no gas will be evolved again. At that point, something has happened. What happened? One of these reactants has been used up. Are we together?
Yeah.
Because for a reaction to occur, we must have two reactants that are reacting, at least two reactants that are reacting together. So if one gets used up, no reaction will occur again. Are we together? Now, that reactant that has been used up, we call it the limiting reactant. What do we call it?
Limiting reactant.
Exactly. That's reactant. Let me say A and B are reacting now, for example. You see, that one that is used up first is the, let me say A is the limiting reactant. Let me assume that A is the limiting reactant. Now, the other one that is not used up, what do we call it? Excess reactant. What do we call it?
Excess reactant.
Excess, exactly. So, during a reaction, limiting reactant gets used up first, while the other one that still remain is called the what? Excess reactant. Now, pay attention that limiting reactant determines the extent of the reaction. What does that mean? Pay attention. What does that mean? It means that whenever limiting reactant, whenever it gets used up, that's where the reaction will stop. Are we together?
Yes, sir.
Exactly. That is when. So when the limiting reactant is used up, nothing will happen again. In this case of magnesium carbonate and hydrochloric acid, let's assume that hydrochloric acid got used up in this reaction now. There will be no evolution of gas again, because one of the reactant has been used up. That reactant that has been used up is called limiting reactant. Hope that is clear.
Yes, sir.
And take note that the amount of products, you see this product, the amount of products formed is directly proportional to the amount of the limiting reactant. What did I say? The amount of what?
The amount of product is directly proportional to the amount of the limiting reactant.
Exactly. What does
I
that
don't
mean?
understand what that means.
Now let me tell you. You see.
Oh wait, no, I understand. Direct proportion is when one thing increase, the other one increase. Right?
Exactly. Yes, exactly. You are correct. It means that, let me take for instance now, that let me say I double reactant A. If reactant A got doubled, because it's the limiting reactant, are we together? It's the one that will help you determine the amount of product that will be formed. Therefore, the product become doubled. Are we together?
No, sir.
Wait, okay. Let me explain again. Don't forget that what is controlling the amount of the products formed is the limiting reactant.
Yes.
The limiting reactant will help you control the amount of product that is being formed. That is, what is that thing that will determine? It's just like as you are at home now. There will be one person that will be saying, okay, let's eat beans today. Let's eat rice tomorrow. Let's eat pasta next tomorrow. Exactly. That's just the person we have here called limiting reactant. Limiting reactant is the one that will tell us the amount of product that is being formed. Okay? Now,
Yes, sir.
now don't forget I said something, and we are going to repeat it together again. Pay attention. Repeat after me. The amount of products formed is
The amount
directly
of products
proportional.
formed is
Is directly
directly proportional.
proportional to the amount of limiting reactants. What did I say?
The amount of products formed is directly
Proportional.
proportional to the limiting reactants.
Exactly, to the amount of limiting reactant. It means that, don't forget I said limiting reactant is the one controlling the amount of product that will be formed. So whenever I double limiting reactant, what happened? The product also double. Are we together?
Yes, sir.
Good. Because we have more reactant particles that we react. That is why, let me say that the time HCl got used up here, I added more HCl. What happened? You have more evolution of CO2. Yes or yes?
Yeah.
Exactly that we are saying here. So
But
if
what
you
about
double the amount of
magnesium chloride? What happens to it?
What do you say?
What about magnesium chloride? What happens to that
Carbonate,
one?
magnesium carbonate.
Huh?
Yes, we assume that this magnesium carbonate is in excess. We are assuming this one is in
Yeah,
excess.
but what happens
But
to it?
yes, it will be still have it remaining in this conical flask. It still remains. All together?
Oh, okay. Yeah.
Exactly. So if you have the amount of limiting reactant, the amount of product also get halved. Do you get that?
Yes,
So
sir.
just take note that when we use limiting reactant to get the amount of product from, just take note that this guy do not even determine the product that is being formed. What controls this reaction majorly is the limiting reactant. All together,
Yes, sir.
that is all. That is just what you need to know about the limiting reactant. Is that clear?
That limiting reactants is what controls the products.
Exactly. What controls the amount of products formed? Okay.
Okay, sir.
Exactly.
But what if they
Okay.
give you like questions on it?
You can't be at your level GCSE. You can't solve question on limiting reactant. It's above you
Let
for
me
now.
show you something. They did.
Okay. Show me.
Hold on.
Okay.
Oh my god, what's my book?
So we still have like three other concepts we want to learn. One will
Oh
be
my
on,
god. Why is most so long?
it's not really that long.
Yeah, I found it.
Mhm.
I sent it, sir.
Okay. Okay, let's see. Wow, seriously. Okay, there's no problem. I'll teach you that. Wow.
I told you that we did it.
Eh, I have a shortcut for you too. Okay, let's
That's why I
go.
thought I was confused because my teacher, she's like, chemistry is not a strong core. It's physics
Okay.
and biology that's a strong core. So she doesn't like teach it properly.
Yeah, sorry about that. Okay, so
Sasaula.
see what yes, I can hear you. Can you hear me?
Yes, sir.
Calm down, you hear me. Just calm down. Please hold on, give me some seconds.
Sasaula, which one is your favorite science?
Everything, everything.
Is
I
your
don't lack in
everything
everything.
is your favorite?
My everything is strong. Biology, physics, chemistry, mathematics, further maths, everything is strong.
Which do you
If
get the
I'm not
highest
strong
mark?
in something, I won't teach you. What do you say?
Which do you get the highest mark?
Math and chemistry.
Okay.
Math and
That means
chemistry. I
chemistry is
don't
your
know.
favorite. The one you score
Yes,
the most is your favorite.
let's say if I'm to grade myself, maths, chemistry, physics, and biology.
So it's calculation part that is your most strongest.
Exactly.
And
Yes.
chemistry being the highest one, obviously your highest score.
Yes. Maths is my highest score, followed by chemistry.
No, like I'm talking about like in science based.
Okay. Yes. Yes. Chemistry. Yeah. Yes. Okay. I'm coming.
I want maths to be my own highest too.
Yeah.
I'm going to do maths for
Yeah. No.
my
No.
A
I'm
levels.
coming. Okay. Now pay attention. Okay. Now see what we have. If you observe this question very well, you will see that we have 108 grams of aluminum, right?
Thank you.
And we have 1.21 kg of copper 2 chloride, right? Copper 1 chloride.
Sasaula.
So, can you hear me?
Yeah. Before you
Yeah.
solve, I don't understand limiting reactant at all.
Yes, don't worry, I will solve it now. I will show you now.
Okay. Can you give me
As I've
some?
explained this, don't worry, you will know how to solve this. Let's go. Let us just go. Pay attention. Are we together?
Yes, sir.
Good. Now, see what we have. Don't forget that this should be converted to grams.
Yeah, I
1.2
converted it.
1,000. What do we have?
That's 1,210 grams.
10 grams. Good. Now, firstly, you have been given the molar mass of all this, so it makes everything easy. Now, let's go. Firstly, calculate the mole of aluminium. Now, the number of mole of aluminium, what do you have? Mass over molar mass, 108 over, what do you have? 27, right?
Yes.
Good. So what would that
That's
give me? Use
four
your calculator.
moles.
4 moles. Good. So you have 4 moles of aluminium. Nice. Also, what do you do here again? Calculate the mole of CuCl2 altogether, copper 2
Yeah.
chloride. So what do you have? Mass over molar mass, 1210 over molar mass of CuCl2. You have it already.
One thirty four point
134.5.
five.
Good. So what do you have there?
Oh, let me get this calculator.
What would that give you?
That means that
Okay.
1210 divided by 134.5.
Mhm.
That's is long.
Just give me to some decimal place. What do you have? About 9 point something, right?
Is 8.99.
Okay, that approximately we have 9 moles, right?
Yeah.
Good. Approximately we have 9 moles. Nine. Good. Now pay attention to me very well. You will get it. It's not hard. Now pay attention. If you observe in this question, see, check. It means that what they gave you in the question is that you have 4 moles of aluminium reacting with 9 moles of copper 2 chloride. Please don't just jump to say, oh, because this 9 mole is greater, it is the excess reagent. Because this 4 mole, no, it is not always like that. There are sometimes that the one that has 16 mole will be the limiting reagent. All together.
Yes, sir.
You just calm down to see how I'm going to attack it. Now, observe the mole ratio of these two. These two that are reacting, observe the mole ratio. Now, let's go. What's the mole ratio, please? Check it out.
Mm,
The mole, check.
two,
What's the mole
three.
ratio? 2:3, right?
Yeah.
Aluminium ratio, copper 2 chloride. What do you have? 2:3, right?
Yes.
2:3. Now, pay attention. Just pick one of these mole. Anyone. You can pick 4 or 9. Pick any one of them. One of them is just pick one of them. All together.
Yes, sir.
Yes, let me say, okay, I want to pick 4. It means that, check, if 2 moles of aluminium react with 3 mole of copper 2 chloride, then 4 mole of aluminium will react with what?
Um, three.
4 moles of
12.
aluminium
No.
react with
Six.
what?
Six.
Oh, yeah,
Six.
it was 4 times 3 divided by 2, right? Do you know I got that?
Six. No, sir.
Oh, yeah, it's just that I'm saying 4 ratio x. Oh, yeah, cross multiply. You observe that 4 times 3 divided by 2. Do you see that?
Oh, yes, yes, sir.
Exactly good. So it means that 2 year 1, 2 year 2, what do I have? 6 mole. Now pay attention. Pay attention. 2 moles react with 3. It means that what the whole 4 mole of aluminium I have here, the whole 4 mole of aluminium I have here should react with how many mole of copper 2 chloride? How many moles?
Um,
How many mole of copper 2 chloride? Check here, check
six.
here.
Six.
But how many did they give us in the question?
9.
Now let me tell you. Imagine I needed just 6, so I went to give me 9. So which one is excess? Which one is limiting?
Aluminium is no. Copper chloride is excess.
Uh-huh. Therefore, aluminium will be what?
Limiting.
Exactly. That's how to get limiting, the one that is limiting. Therefore, aluminium is limiting. This is the easiest way you can just do it. Is the limiting reactant. See, be doing it this way and you don't fail it.
Wait, sir. Sir,
Ah,
don't explain it. I've never written it.
okay, I'm coming. Aluminium is the limiting reactant. Why say you Cl2 is the excess reactant? Is the excess reactant? Yes, that is the excess reactant. That's how to know. Imagine I needed just 6, so you went to give me 9. Ah, you are giving me excess then. So that's the first way to know what's the limit. So let us now look at the question. The answer that was calculate the mass of copper produced. Now pay attention. This is how you now learn. If you are done writing that part, let me know.
Okay, sir.
Mm.
Mr. Saula,
Yes, I can hear you.
why do we have two different ratios of aluminium to copper chloride? We have 2 to 3 and 4 to 9.
Okay, where is it? No, 4 to 6. Check. 4 to 6.
Yeah, why do we
This
have
one
two
that I did.
different?
Which one? Okay, you remember that? Okay, like for example, like this 9, right?
Yeah.
Remember, we are trying to test how many we are going to need out of the 9. So I just kept that 9 somewhere. So if I get a number like 12 moles, it means that I needed 12 moles. They went to give me 9. So is that limiting or excess? It will be limiting. So we are just trying to know if this 9 is sufficient or not. So that's why we are keeping it. So we are not even using it altogether.
Yes, sir.
Yeah. Don't worry. If you have more questions, we are going to solve them. I don't write it.
Yeah. Almost. Seriously. Yes, I'm done.
Nice. Now, this is what we have. Okay, remember the answer that one. We should calculate the amount of copper. You see, let me tell you one trick. When are you going to know that you have to calculate limiting reagent, even if they did not ask you? You see, if they are giving you the quantities of the reactant, both of them, they are giving you together. The two are not useful. Only one is useful. That one that is useful is the what limiting reagent. Remember when I was explaining limiting reagent, I told you that the limiting reactant, it is the one that will determine the amount of product that is being formed. Yeah, yes or yes.
Yes, sir.
So it means that they give you the two quantities of the reactant, you need to determine limiting reagent. So is that limiting reagent you now use and solve for the product? I don't need this mole of CuCl2. This one is not needed again. Don't forget. Now remember, which one will I be using to calculate copper? Is aluminium. Why? Because it's the limiting reagent. Okay.
Yes, sir.
Do you get that? Exactly. Now let's go. So we want to calculate the mass of copper produced. First, let's look at the mole ratio between aluminium and copper. I'm using
Two
aluminium
to
because
three.
it's the limiting reagent. So it is 2:3. Yes or yes?
Yes.
Now, yeah, the mole of aluminium I have here is what? 4 moles, right?
Yeah.
Good. 4 moles will give me how many mole of copper? X cross multiply. What do I have? S equal 4 times 3 divided by 2. 2 here 1.
Six.
That give me 6 moles. I mean, so 6 moles of copper is produced. Now, as 6 moles of copper is produced now, what's now the mass of copper produced? I think it's the mass that's us to find, right?
The maximum mass. Yeah.
Yes, that's not exactly. So
So we'll do MR of copper.
that's
Uh,
mole times molar mass. Are you there?
yeah, copper
What's
is
the mass? 6 times what's molar mass of copper? 63.5.
63.5.
Now, calculate both of them. What do you have?
Come in. 6 times 60. That is 381.
3 what?
81.
381 what? Grams. That's it. You see that if you give this out to your teacher now, you are going to get it. So make sure you write it. Okay?
But I failed it.
Nice. Whatever limiting reagents question, bring this. You see that. In fact, let us only do limiting reagents for today. Okay?
Okay.
But yeah, do you have any other limiting reagents question?
No.
This is the only one that is inside the text.
No, this one was a test that we did.
Yeah. Okay. I'll come. Okay. Are you the writing?
No, no.
Okay.
Done, sir.
Good. I'm coming. Let me write another one on limiting.
Wait, but sir, how come you
What is
guys?
it?
How
Yes.
come you did limiting reactants in um,
Mm.
100 level and they are forcing our brain to understand it at?
No, our own is hard now. If I give you my own here, it's very hard. Okay, let me tell you. No, not that it is like the way they will twist it. Number one is not as direct as your own. And number two is that what makes our own hard was that it's still the same concept, but it is that our own they can say, okay, which are the limiting reagent, which are the excess reagent. By how much is this one in excess? By how much?
Oh,
Again, they can link this question to percentage yield. So it will be extreme in our own, but it's the same principle.
I
It's the same
understand, sir.
principle. Yeah, it's the same principle. Yeah, but we did it on the level, not even secondary school. Secondary school, I never even learned limited reagent. Okay, I'm coming.
It's not first. I'm going to go and fight with the education board.
Yeah, really. Remember, we are using different curricula.
Yeah, that's why I say
So
I'm going to fight
there's
with the
the
education board.
one in Nigeria is different. Oh, yeah, next, let's look at this one now. This is the last question we are solving. So just pay attention. So you are still looking at limiting reactance question. Okay, 9.2 grams. That's it. Now, are we ready?
Yes, sir.
Pay attention to this. Now, let me be right. So Na, I'm giving you as 23, S is 32. So if this one did not give us equation, but we are going to write it. So sodium reacted with sulfur. Sodium is Na. It reacted with sulfur. What's sulfur? Sulfur is S altogether.
Yes, sir.
So how do we write? We write the equation this way: Na2S altogether.
Yes, sir.
That's sodium sulfide. You can see what they give you here: sodium sulfide. So we have to balance the equation. We check how many sodium do we have here? 2 sodium,
2.
right?
Yeah.
So check. Don't mistakenly put 2 here. It's wrong. Whenever
No,
you are
it's a big
balancing,
2.
exactly, big to good. Now, we want to know they gave us 9.2 grams from the question, and they gave us 8 grams of sulfur from the question. So firstly, let us find their moles, right? Are you there?
Yes, sir.
So mass over molar mass. So 9.2 over molar mass of sodium is 23. So we calculate that. Please use your calculator for that. Also, you calculate mole of sulfur, and that's mass over sulfur is 32. So let's calculate the mole. What do we have here?
0.4
So the first one
for
is what?
sodium. 0.4 for sodium.
So let me just say 0.4 mole of sodium. 4, right?
No, just 0.4.
0.4 mole of sodium. Why this one? What do we have?
For sulfur, we have 0.25.
25 mole. Nice. That's the first step. Now, the next step is that look at the mole ratio. Compare the mole ratio. All together, compare the mole ratio, okay?
Yes, sir.
Now, I'll just continue here. Now, check what we have. We have sodium ratio sulfur. Now, according to this stoichiometric equation, what's our mole ratio? Can you tell us?
Our mole ratio is 2:1.
2 to 1. Thank you. Now, remember, I want to know which of these reactants is limiting.
Is limiting.
Now, check. According to the equation, 2 moles of sodium react to 1 mole of sulfur. Now, let's check 0.4 mole of sodium. We react with how many mole of sulfur?
0.5. 0.25.
So check. So we have 2x equals 0.4. What do we have? 0.4 divided by 2. How together?
Yes, sir.
So what do we have? This will give us what? 0.2 mole altogether.
Yes, sir.
So therefore, it's like they are saying 2 moles of sodium will react with what? 0.2 mole of what? Sulfur. Now check this statement. This, sorry, I mean 0.4 mole, sorry, 0.4 mole of sodium will react with 0.2 mole of sulfur. Are we together?
Yeah.
Now check. We need just 0.2 mole of sulfur to react. We needed just 0.2 mole of sulfur to react. And check, how many moles were you given in the question? After you calculated it, how many moles were you given?
0.25.
Now check. I needed just 0.2 mole of sulfur to react. And they gave me 0.25. Now check. Is sulfur in excess or is it the limiting reactant?
Is
The
in
text that
excess.
is in excess exactly because I needed 0.2 mole and they are giving me 0.25 mole. So how do I
Zero-
conclude? I'll say therefore sodium is the limiting reactant. Is the limiting what? Reactant.
Reactants.
Why what? Sulfur is the what? Excess reactant. Do you understand that? You don't understand
Yeah,
it?
I understand, but sir,
Yes.
why do you put
Yes.
0.4? Why can't you put 0.2 instead?
Oh, why can't I put 0.
25 instead of the
Okay,
0.4.
no problem. Anyone you do, you are also correct. Now check it out. You will see I can use any one of the two. It's just for me to detect. Check it will work. The mole ratio is still to 1. Now, I don't want to check for this. Now, let me now check 0.25, right?
Yeah.
Yeah, let's go. 0.25 mole of sulfur will react with how many mole of sodium? Let's say y. Let's cross multiply. You will see. Y equal 2 times 0.25 will give me what?
Uh 0.5.
No, 0.3. Take that. 2 times 0.25.
Is 0.5.
2 times 0.25.
Yeah.
That's 0.5. Sorry. Oh, 0.5. Sorry, 0.5 more. Thank you. Now, what do you observe? I have 0.5 mole of sodium. I needed 0.5 mole of sodium, and they gave me 0.4 mole. Check. Oh, I need 0.5 mole to react. They now gave me
Oh,
0.4.
that's limiting. Oh, I see what you're
Exactly.
saying.
Whichever you use is correct. Do you understand the concept?
Yeah.
Exactly. That's how we run it here.
Sir, can you go back up, please?
Okay, no problem.
Thank you, sir.
Mm,
A bit up more, sir.
okay.
I've not written a question. Thank you.
Okay.
Sir Saula,
Yes, ma.
after we finish limiting reactants, which other one are we
Mm.
doing?
Our next class is now beyond. We have 2 more things to go.
Okay.
What are we going to learn? You are going to learn about gases and solution. Very important. Also, learn about how to calculate concentration. Then lastly, percentage.
Gases. I don't.
Don't worry,
Sorry.
it's same thing that you know. And concentration. Then we look at percentage. That's all. After that, if they give you any question on percentage on mole concept, you will surely have the idea. There's no way you understand.
Now we don't do gases.
Don't worry. It's like you don't do it, but they not just tell you the ending, but it's part of what
Okay.
you do. Yes, you
Okay,
might
sir.
not be using the same ending, but it's the same. Yeah, don't worry. Trust the process.
Okay. Oh, so we still need to calculate the mass.
Yes. The mass of Na2 is good. Now let's go. Are you done
I
writing
don't
this?
know, sir. No, sir.
Okay. Yes.
Sir, can you scroll down, please?
Is that enough?
Thank you, sir. Sir, can I copy the other one that's down? I'm done, sir.
Good. So the last thing is now to calculate the. At times they might not ask you which is limiting, which is excess. They can just say calculate this one directly. But
Okay, sir.
you have to first determine the one that is limiting. So you know the one you are going to use. Now the one that is limiting is what? Sodium, right?
Yes, sir.
So we are now using sodium to calculate Na2S. That's just what you need to do. So we have Na ratio, Na2S. Now, what's their ratio from the stoichiometry, from the equation?
The ratio from the 2:1.
2 to 1, thank you. Now, what is now
Sir,
the
wait,
mode of
before you go to
sodium
the next step.
calculated in the question?
Sir,
What now the mode of sodium calculated in the question?
0.4.
0.4 exactly. So that's 0.4 mode of sodium.
Sir,
We give you one mode. Are you there?
yeah, are we using sodium to calculate the product? Because you said the product
Sodium
is
is
directly proportional to the.
exactly, yes, that's it.
Okay.
Because the limiting
So every
reagent
time you are looking for
is
the
the
product, you use
commander.
the limiting
Exactly,
reactants.
exactly, all the time. All the time. Yes. So let me say x cross multiply. So what my answer? 2x equals 0.4. If you divide both sides by 2, s equals 0.2 mole. And we have to get the mass. So what's the mass of Na2S? That's mole times molar mass. Now, what's molar mass of Na2S?
They put it in the question.
23 times 2. No, I'd not put it. Let me just tell you. 23 times 2, that's 46. 46 plus 32. 46
Um,
plus 32. That gives me
46.
78. Are you there?
Yes, sir.
So
78.
let me say, yeah, 78 good. So let us now say this is 78. So times 78. So what do we have? Yeah, multiply.
Sir, can you excuse me for just a minute?
Okay.
Thank you, sir.
We are almost done. Hello, hello.
I just want to quickly use the toilet. I'm really
Okay,
pressed.
okay, no worry.
Sir Saula.
Yes, are you there?
Yeah.
So multiply these two for me. What do you have?
0.2 times 78. That's 15.6.
15.6 grams of Na2. So that's how to do it. So with this, you are good to go on any question on limiting ranges. So that's where we end the class. So I will help you send the video. I've recorded all this, so I will help you send it in case you need it next time.
Okay, sir. Thank you, sir.
Bye.
Bye bye, sir.
Yeah, take care.